Now, I'm going to find out the power and energy of a particular signal. Suppose if there is any signal x of t, it can be a power signal or energy signal. Power signal cannot be energy signal. Energy signal cannot be power signal. Power signals are periodic signals. Periodic signals. Whereas energy signals are non-periodic signals. Non-periodic signals. Suppose if power is infinite, then the energy is finite. Suppose if energy is zero, just a minute. See. X of t is an energy signal if and only if x of t is energy signal if and only if it has finite. E is finite. E is finite. And the power is zero. Power is zero. X of t is a energy signal. When the signal is said to be energy signal, whenever E is finite, power is zero. When the signal is said to be power signal, when a signal is said to be power signal, average power, we need to consider both energy as well as power. The average power is finite and the energy is finite and the energy is infinite. These are the two conditions you need to remember, whether the signal is energy signal or power signal. Okay. Once again I am going to repeat. X of t is an energy signal if and only if energy is finite and power is zero. X of t is a power signal if and only if energy is infinite and the power is finite. Clear? Okay. Now let's solve a problem based upon this. Let's solve a problem for a given signal and let's calculate the power as well as the energy for the given signal, whether it is a power signal or energy signal. We need to check whether the signal is power signal or energy signal before calculating the power or energy. The formula for power is now A. This is the signal given, which is equal to, which is given by x of t, whose amplitude is keep on decreases exponentially like this manner, which is a e power minus a t into u of t. Unit of t is a unit step function which is occurs only for t greater than equal to 0. Okay. Now the formula for power is equal to limit L tends to infinity. Instead of L, I can mention T also for periodic signals by 2L integral minus L2 plus L x of t whole square. This is the formula for power. The formula for energy signal is E is equal to, okay, E is equal to is equal to limit L tends to infinity integral minus L2 plus L x of t square. The major difference between power calculation and energy calculation is for energy calculation there is no 1 by 2. Okay. In order to get the power from energy, we need to include this 1 by 2 in the formula. Now, I'm going to calculate power as well as energy for the given signal. First of all, we need to check whether it is a power signal or an energy signal. If it is a power signal, means we need to calculate power. Okay, let's find out the power solution. P is equal to limit L tends to infinity. L tends to infinity. Sometimes we need to replace this L with T, capital T. T is period of the signal. Suppose if the signal is periodic, we need to mention T instead of L. L tends to infinity 1 by 2L integral minus infinity plus infinity A e power minus AT whole square into U of T. Actually, I need to keep this U of T. To keep this V of T in the brackets. V of T. Here, U of T, I'm going to mention the V of T diagram. This is V of T. See, U of T is valid from T is equal to 0 onwards up to T is equal to infinity. Means it is U of T is having a value of magnitude 1 from the ranges T is equal to 0 to. So we need to substitute these limits in this equation. That is limit L tends to infinity 1 by 2L integral. Now instead of minus infinity to plus infinity, based upon the limits of U of T, I need to change the limits of this integration from 0 to A square e power minus 2AT into A square is a constant you can take out from the integration. Limit L tends to infinity 1 by 2L A square integral 0 to infinity e minus 2AT now, which is equal to limit L tends to infinity 2L A square into e power minus 2AT by 2. You need to substitute the limits for 0 to see the integration of e power minus 2AT is e power minus 2AT by 2A. This will comes under denominator, right? Now, now, now this can be written as no. See, now substitute the L tends to infinity means you need to replace this L with infinity. What will happen to this entire power? The power will become the power is infinity. The signal is energy signal. The signal is it is energy signal. The signal is energy signal. Is it clear? Is it clear? If they, the power is infinity means that it is a given signal is a energy signal. The formula for energy is for the signal L tends to infinity L minus L2 plus L A e power minus 2AT whole square, which is equal to I need to substitute the limits as I need to substitute the limits as limits attention to 0 to L only because we are having u of t here. Okay. Based upon the u of t function, I have replaced with minus L2 minus I have replaced with minus L with 0, which is equal to a square e power, made a mistake, just a minute. This is minus 2AT. Now the integration is for again limit n comes to infinity a square into e power minus 2AT by 2AT by minus 2A. You need to substitute the limits 0 to a. Finally, this is equal to a square into e power minus 2AL minus 1 by 2A. This is minus limit L tends to limit L tends to as L tends to infinity, as L tends to infinity, this term will become 0. So the final value minus of minus we are going to get as a square by 2A, a square by right here. And GE is equal to a square by 2, which is finite value. So the given signal is a energy signal. Once again, I am going to repeat. A signal is said to be energy signal. It has finite energy and infinite power. A signal is said to be power signal. It has finite power and energy is zero. Is it clear, students? Thank you. Thank you. You need to remember this conditions along with these two formulas. Got it? Thank you. Thank you very much.